All right. Hopefully everybody's back and refreshed. You had a nice lunch, some beverages, and that your brain's clear because we're about to fill it again. Our next presenter is Jeff Curtis. He is a retired diesel instructor from Bellingham in Washington. He's a native West Coaster, like many of you here. Jeff is going to talk about diesel emissions. It's also important to note that he is a former president of NACAT because Consulab's a big supporter of NACAT and many of the other national organizations out there. That's a major part of what we believe in. So go ahead and take it away, Jeff.
Thanks, Jimmy. Somebody key me when you can see my screen.
Got it.
Got it? Okay, thanks. So today we're going to go through the EC, actually we're going to use the EC490 diesel after treatment system to demonstrate exhaust gases in a diesel after treatment system with SCR. Now this presentation will be mainly about SCR, or selective catalytic reduction. And this is the portion of the system that uses diesel exhaust fluid, DEF. So this presentation has been compiled since DEF and SCR first came out. So in 2000, I believe it was 2010, I went to a Freightliner factory class at the Freightliner Training Center in Portland, Oregon, and went through a class on diesel after treatment. And since then, it's been a great interest to me to see the evolution of these systems and how they all function, and also to listen to the urban legends about many portions of how people think the system works. There's some chemistry involved that I have to trust the scientists for, and the people that are smarter than me, but I can follow along a little bit. And we're going to do this with this, like I say, the EC490 after treatment system. I wrote the curriculum pieces that we have, which is a very visual demonstration for the students. I count myself as one of those visual learners that I really need to see the pictures of it. So this is a lot about how we design the tools as well. The education team has been tasked with how do we promote student learning, and how can we help the instructor promote student learning. So that's what has brought about some of these tools. So taking the mystery out of selective catalytic reduction, see, it doesn't even roll off the tongue real well. Selective catalytic reduction. And we can see down here at the bottom, if you're a chemistry teacher, you could go through the chemistry. Now I make a little light about that right now, but if you've got connections within your campuses with the chemistry teacher, if the academics on campus are always questioning what you are doing, I believe that a study of SCR with the chemistry department might be something that we used to talk about teaching across the curriculum, and this would definitely be a method of teaching across the curriculum. So we'll look at all these components and as they travel through the system. But first we have to set some baselines for what is our atmosphere. What are we currently dealing with? The people on the West Coast, especially California, I don't have to talk to you about air quality and the standards that we have to meet. But we need to understand some things about what are the materials or components of combustion that we have to deal with. And a big one up there, of course, is nitrogen, it being 78%. And oxygen at 20%. We don't seem to have many problems with the other components, the argon and some of the other gases. But we're really, when we heat up combustion, we produce those oxides of nitrogen, which turns into the dirty atmosphere. You'll see I've tagged at the bottom all my sources. I try to use open source as much as possible so that we don't get in any copyright issues. So everything here has been tagged. To the point that I don't project a saved copy of this particular link that I'm going to use as a drawing. Now, this is a link to a Ford file. Here is the document number, and that 1701.pdf indicates that we're talking about a model year 2017. If you're dealing with a model year 2018, all you do is put 18 in place of the 17. All the way down, I think I've found it as far as 2014, and I don't know that I've checked for 2019 or 2020 yet. So this document is about 200 and it's over 200 pages. We're mainly going to look at one page, but if you're teaching emissions, I would suggest that you really pay attention to this document. You know, the heavy duty guys are going to say, well, it's not Caterpillar, it's not Freightliner, it's not PACCAR. That's fine. These all work the same. There's really no difference in how the system operates and the outcome of the system. So we'll go through this, and I will show you this document. Right now, I am going to show the document and also to tell you what I'm doing and my comfort level of presentation. I like drawing on iPad screens to try to make things visual. So what I've done is I've used a tool called Reflector, and I am sharing my screen wirelessly through my wireless network with you, and the screen is of my iPad. Okay, so I'm going to scroll through. Oh yeah, that's right. You can't do that, Jeff. I have to think about that each time. I'm going to scroll through this document to a graphic, but you can see how well it's organized. And I'm going to go into, I believe it's page 8. So there's 7 and there's 8. I get the right system. There's a couple of different systems that are certified. This is the system that we have. Some of you are, when I get to the end of the exhaust system, I'll answer some questions about the placement of each of the individual components, the dock, the SCR, and the particulate filter. But first, I want to call attention down here. I want to do some drawing. Enabled my pen. So you can see my green screen, green highlight comes in, and I want to highlight the incoming air and then stop and make a point. So notice that the green that I have highlighted comes in through the air filter. So this is atmosphere. And you know, the point I'm trying to make is that this is a closed system. So we are measuring that air. Mass airflow sensor is going to measure the density or whatever is coming in. And for a beginning student, I think maybe even that's just enough. We're measuring everything that comes in, and then we're going to measure everything that comes out. So I'm going to change my pen color here to blue, because now we're in the turbo, and we go through the turbo, and we you know, we cool it in the watered air aftercooler in this case. Here's a temperature sensor. We've got a throttle plate in the pressurized exhaust stream up through to the cylinders, all the way up on this V8. This is a 6.7 liter Ford. Now, let's switch colors here and go to out of the cylinder. We come out on both sides. These are exhaust gases. So I got to turn this off. Scroll. Easy. Come back in and we'll complete the drawing here. So here we've got some pressure sensors. We have a variable geometry turbocharger, exhaust gas temperature, turbo outlet, diesel exhaust or diesel oxidation catalyst. And we get to the dock. So diesel oxidation catalyst is really no different than any oxidation catalyst. I'm not going to spend a lot of time explaining that because those have been around since what, the late 1970s on cars, early 80s. So then we're going to go through several other sensors. You know, there's an aux sensor here, turbo outlet temp, selected catalytic inlet. So we're doing a lot of temperature and we're doing some pressure and we're also measuring oxides of nitrogen along the stream. But here we come across the SCR system and the injector, the urea injector. So Ford's going to call it SCR system reductant because the SCR reaction is a reducing reaction in what I've been told. That's my high school chemistry coming out. And then we go through the selective catalytic reduction, outlet temperatures, diesel particulate filter, and on out. Of course, it's got to sound cool, so we have to have a resonator. And then you can see all the other sensors that are involved. And then up here at the key, the explanation of all those sensors. So it's a pretty interesting system. I like to go through and try to give students a map, wayfinding in the system, because many folks, even journeyman technicians, do not understand how these systems work. And they don't understand the interrelationships of all the sensors that are all talking on the bus. You know, those decisions are all being made by computers. You know, on heavy trucks, heavy equipment, the exhaust system oftentimes has its own computer system. So they need to know and understand, excuse me, the relationships that happen with those. So I'm going to switch back to PowerPoint. Let me just highlight this urea tank and the heaters and other things that are going on in here. There's a pump, right? There's an inline heater. There's a tank heater. There's a number of things that can go wrong here. And even the littlest thing is going to have an effect on the operation of the system. So we really need to know a bit about it when we take off with it. Okay, let me get rid of this. So system architecture, we're going to look at a bit here on what makes the thing work. So I'm going to use a different drawing method so that I can draw right within my PowerPoint. So I've got this this nice laser pointer, but sometimes I want to draw. I like using the whiteboard, and it's difficult when I can't see my mouse. Interesting. Hang on a second here. There it goes. So let's get into the highlighter. I'm just going to use yellow for expediency. I can come in with my pen. This is a Wacom tablet. It's about, I don't know, 8 by 9, and it's very positional, very accurate. So here I can draw the inlet air coming in. Here is the diesel oxidation catalyst. So here's where we get rid of hydrocarbons essentially. And then here is the injector for DEF that I've just highlighted. Here's a grill to diffuse the mixture. Here's a swirl chamber or decomposition tube where we decompose the water out of the diesel exhaust fluid mixture, which is made up of 32.5% urea, and the rest is deionized water. Now, something that we had to do on this trainer is we had to cut it in half to make it fit on a board. So when we cut it in half, we did this because it was like 8 feet long, right? And it's just is difficult to do anything with. So we cut it in half, and then we cross-sectioned it and split it in half. So these are used components. They've actually been in service, and you know, we have some people back in Quebec that are just very good at this, laying this stuff out. So we spent quite a bit of time around it, and we also spent some time debating, actually a fair amount, of do we change the direction and make it this way, or do we put this bottom piece on the other way? And we just decided that this made more sense to continue the exhaust flow this way. So we've come from the decomposition tube here, and we're now into the selective catalytic reduction unit. And this is a ceramic substrate with metals washed on it, like palladium and the typical things that we're used to in these types of substrates. The mixtures, of course, are probably proprietary, but anyway, it reacts with the urea in the system and is going to convert oxides of nitrogen to the nitrogen that we're used to in the air. So the NOx converted to N2 as we're used to seeing it in the atmosphere. So this is a pass-through like a diesel oxidation catalyst, right? These aren't blocked at each end of the little passages. They pass through, and it's the reaction or the reductant reaction that happens that reduces the oxides of nitrogen. Here now, the next piece in line here is the diesel particulate filter. And I know that the heavy duty guys are going, you know, that's kind of backwards for us. Our diesel particulate filter is in front of the selective catalytic reduction unit on big trucks. And what I've heard from engineers is it really doesn't make any difference. And so Ford puts it in this spot on their pickups. Okay, and then we're going to travel. This is actually a blocked passage and a porous ceramic substrate that operates more like an air filter than it does a pass-through. So what are we collecting? We're collecting soot. And because we don't want to see any black smoke coming out of the engine or out of the exhaust pipe, all the black soot gets caught up here. Well, first off, we want to make sure the engine's running correctly, right? So if we're burning oil, we've got a worn out engine, you know, we've got things going on, this will plug faster. It'll soot load. And there's temperature sensors, pressure sensors that are going to tell the computer that, hey, you know, we're getting plugged up here. We need to have a regeneration. So the regeneration cycle will add fuel upstream so that we can add heat downstream so that we can burn off the soot that leaves ash. And the soot physical component of soot is bigger than the burned off or cooked ash. So what's eventually going to happen, of course, is that the ash is going to build up in here, and probably you'll need to replace the system because this one doesn't appear to me to be serviceable. It's all welded up tight. Now, in the big box systems of the middle 2000s, and then to the smaller systems, the emissions year 2014, those have been, sizes have been reduced. They've tightened up the specifications on it. But the point here, I believe, is for the student to understand the system and what's going on within the system. So we're going to filter out all the particulate, and coming out the exhaust tailpipe should be nothing but good things. So let me switch my pointer. Okay, same thing. I'm just going to follow through with the laser pointer. This is in, so right off the turbocharger, got a, looks to me like a temperature sensor, sticks down in the stream. It is a temperature sensor. Goes through the diesel oxidation catalyst, through the DEF injection area. So there's some, you can see some sensors here as well. Looks like another temp sensor, and maybe that's the NOx sensor there. A grill to break up the stream coming down against it. The decomposition tube to remove the water and end up with, separate the water because of the heat and come down through. And the urea is used here within the selective catalytic reduction unit to reduce the oxides of nitrogen. And then we go through the next chamber. There's another temperature sensor so that the computer knows that the temperature is at its proper level so that we can start a regeneration. Now, this is a pretty interesting process. When I was at Bellingham Technical College, the automotive program bought the first 6.7 liter diesel engine trainer that Consulab built. And we saw it originally at an ACAT conference in Quebec. So like 3 years later, I think the year that I left Bellingham Technical College, Dan Beeson invited me down and he said, hey, we're going to do a regeneration. You want to bring the class down? So this is the first regeneration that had been done on this engine trainer. And the engine trainer had been started and stopped, started and stopped, started and stopped, never brought up to temperature. So we felt that it had generated some soot. You know, I used it down in diesel. We used it back and forth. Great trainer, really has a lot of positive attributes there. And then I took a video with a thermographic camera, and we followed the heat path from the engine and out the exhaust as Dan, I'm going to say instigated, but he initiated a regeneration of this unit. And it's fascinating. If you want to see that, search your YouTube and just JCURTIS 4082. And maybe one of you guys could throw that up in the chat. I'm not trying to sell my YouTube channel because those were all made at a college, and I received nothing for them because it belongs to Bellingham Technical College in the state of Washington, which is fine. You're free to go in and view those videos. They're fairly short. Okay, let's move along. Oh, before I move, take a look at the lights here. So there's a, if this was a map, this would be the key, right? So I always look at engineering drawings, I look for keys, maps, I look for key because that tells me what everything is. So you can see that there's a bunch of different colored lights, and these lights are all tied to the different gases that travel through the exhaust system. And you can see that at various points in the system, those lights would correspond. So we could simply toggle the hydrocarbons and watch the hydrocarbons as they travel or do not travel through the system. We could watch the oxygen. And of course, we really want to be able to watch the NOx, where that's removed, and the diesel exhaust fluid here. So they're all different colors. They flash, you can speed them up, you can slow it down. And with that, I'll stop my sales pitch on that. It's very visual, and all the assignments are tied to that. So speaking of assignments, I think I have this up as my background. I don't see myself in the screen, but this is a graphical representation of the system as built by Ford. These are our drawings. We also have engineers that do really good educational drawings as well. I would draw the turbocharger probably a little bit different, but I think you get the idea. This is going to be exhaust gases. You know, if it was technically correct, you would see that this is the compressor side, and that would be compressing inlet air. But we're using the exhaust gases for the example here. These are going to travel through. Here's the diesel oxidation catalyst, more sensors, more things called out, the injector, the decomposition tube. We turn the corner. I'm going to make a point of this several times in this presentation. We're going to turn the corner this way, and then we're going to exit out here to the end. So we've turned the corner, we're in the selective catalytic reduction, and then we're in the diesel particulate filter. So let's get started. So there's some tags for you. I'll let you look at that for a second. Just to get your bearings within the system. We'll go back to this. We're going to talk about a fair amount of this. So here's one of the first assignments. Assignment number 4. I wanted to show the exhaust gases coming in already labeled for presentations like this for instructors. So as you can see off to the left, here's our components coming in. I hate to say gases because particulate matter is not a gas. It's a solid, but these others are gases. This is coming from the turbocharger, going through the diesel oxidation catalyst. Here's our component gases out, so, and the particulate. So remember this as we get to the next one. So you see this is coded with the instructors. This is the instructor's document. This is all included in the educational materials available for this product. So here is the student version where we've allowed them to have, you know, I've got student versions where they have to color in with color crayon the colors. That's a little pedantic for right now. So I just left the colors in, and we know that from the other side, this previous slide, okay, on the right-hand screen, these gases come out, and on the left-hand side, these are the same gases that go into the injector area for the DEF fluid coming from the DEF tank being pumped in. And then there's the grill here. There wasn't really a good way to show it, so I didn't. And then the spiral mixing chamber, where we mix all this together so that when we send these gases out, look at, we have more here than what came in because we're starting to split some of this out. Okay, so this is student version, so this would be an assignment. The student needs to, has the ability to go to the trainer and visually see which of the component gases are moving through the system. So this is the method to my madness here is not to necessarily teach high-end chemistry, but I just want them to know that these components and just these components are moving through the system. So Rick Martineau and I were in Quebec a couple of years ago, and we ran into, or a gentleman came over and wanted to look at our training materials, and he was telling us their troubles. He was in the maintenance department, and this is a fleet of over 1,000 power units, and they were at this time, that was must have been 17, I suppose, 16 or 17. They were having trouble finding people to repair their exhaust after treatment systems. Even the dealers couldn't find out the problems. So they had one truck, I don't recall the brand now, but it doesn't really matter, that every 40 miles it would set a code and start a derate because it wasn't seeing the right things in the exhaust stream. So the common fix was to, and one of the more important, one of the more expensive components is the NOx sensor, and it was throwing a NOx code. And so each place it went, it got a $700 sensor plus the labor, and then 40 miles down the road it had set a code. And so this truck made its way across Quebec and down into New York, and they're trying to make their freight run. And finally, I believe it was 5 or 6 stops, a couple involving a tow. They made it to a dealership where the technicians understood that this is a closed system. And when they opened up the side of the exhaust treatment system, they found that the calcium chloride and the road salts had eaten a hole in the exhaust system. So it was akin to having an air leak on the measured side of the mass airflow sensor. So we're introducing outside atmosphere into the system that's not measured, and it can't handle it. You have to, you can't have leaks. So this is one of the things that we walked away with from this is the importance of the integrity of the system. And that's more what we're trying to have students understand is how, when a truck shows up into their bay, how can they fix it? Okay, are they going to fix it by studying the chemical diagrams? Well, I'm not so sure. That might help them. They need to know what the components are within the system, but maybe it's more basic than that. Maybe we need to work on the basics a little. So the instructor's version of that previous slide. So we went from here to here, and here we show again the gases, CO2, NOx, water and particulate matter. And then we come through and we end up with these coming out of the decomposition tube or the spiral mixing chamber. Okay, once again, I make the point of we're going to turn the corner, and our exhaust flow now is going to change from left to right to left. That's the only reason for this. So here we are. We're looking at the system from the exhaust flow from right to left. And we take these 6 components, and I say components again because there's particulate matter here, and 5 components of gas, and we're going to end up with 4, one of those components still being particulate matter. And what are they? Well, you're the instructor, so they give you the books with the answers in them, right? So here we are. We're at the tail end of the string here on the exhaust system. Look at the temperature sensors, NOx sensors, component gases and components, particulate matter included. And what we end up with are CO2, nitrogen, and water. So with all these other components along the way, we end up with pretty much what we want. And this is a clean exhaust. You know, if you, city buses, I've always kind of marveled at those. They have an overhead exhaust, and it's like that ET, you know, phone home ET, that head on the exhaust. It's made, in my town, they're made of stainless. And the diesel buses, stop and go, one of the worst applications you can get. And those things are spotless. You could take a white glove and wipe inside the exhaust, and they're absolutely clean. And they've told me that, you know, they have very little problems with them. But the problems that they do have are brackets, wires chafing, you know, the common things. So it's the usual things. We don't want students to high-tech this. We don't want them to get lost in the weeds. We want to be sure that they do the basics first. Okay, pause for a second. Some feedback, guys. Do I have anything in the chat that I need to, or the Q&A that I need to address before I move on? Besides, I need a drink of water.
Yeah, you do have a question here from Jennifer Montero, who says, I'm sorry, Jeff, you already mentioned it, but what app or program are you using to use the pointer and the labeling?
Oh, okay.
That was
Two different ways. So the app, this one, you should be able to see in the bottom, well, it's right there. That's Reflector 3. And Reflector, you do a web search on that, you can find that very easily. So I can project my phone, my laptop, and my Apple Mac and my iPad to my PC. So that's where that comes from. Okay, anything else? Let me take another sip of my tea here. I'll give you a second to read this.
Isn't there a highlighter feature in PowerPoint too, Jeff?
Yes, there is. I just wanted to show a couple of different things too.
No, I understand. She just said a couple of different ways, so I knew there were.
Yeah, yeah. So here we're talking about the diesel exhaust fluid, and you know, you hear it, AdBlue, for the automotive market. Diesel exhaust fluid is a 32.5% mixture of urea and deionized water. Why 32.5%? Well, apparently at freezing points, that this particular mixture, they don't get separation. It freezes evenly if it does freeze. Often it's more of a slush until you get really cold. And I've worked in Alaska. I talked to those guys up there, and you know, they're having some, you know, there's some things going on, but they're getting a handle on it, because now even the mining trucks, Tony Martin works up out of, I can't think of the name of the company, but up out of Fairbanks, and they're 789 Cat, or 793, I guess they are, Cat end dumps.
Fairbanks Gold Mining Company.
Yeah. So they are, their after treatment systems are huge on those big mining trucks, and they're using 32.5% urea in that. Now there is another standard. It came up the other day. Somebody asked about it, and the marine standard, I believe, is a higher concentration of urea, so they don't have to carry as much of it around on the ship. So those systems are designed that way. Where did I find this? This is all Wikipedia stuff. I mean, you can go in and check that, and I always check references, and the documents referenced are spot on. So that's diesel exhaust fluid. It's it's 32.5%. It's not 33%. It's not 31%. So the accuracy of the fluid is something we're going to talk about within this presentation yet. So we'll read about urea. And I'll leave urea at that, except now, why do I put something like this up? I put something like this up because I hear urban legends or just flat misinformation from equipment operators and truck drivers. I'll pick on the operators first, but I think mostly this has come from the truck stops across North America, to the point where people put other things in the diesel exhaust fluid tank. So I'll just let your imagination run wild there, and that's probably what has happened. So one of the things that we did at the factory training class for Daimler was we tested DEF fluid, and we tested many other things that had been represented by someone else as DEF fluid. So, you know, some of the stories I hear are that, well, I just poured windshield washer fluid into my DEF tank. It was clear, and I figured it would be all right. Or, you know, I just put water in it, and now I can't understand why I have a D rate. So I could be caught on the exact sequence of events that happens when you don't have the right fluid in this, but it's a rather short period of distance, and I'm thinking under 25 miles, that if you ignore the DEF quality issue, you're going to be parked alongside the road. Because part of the EPA's directives when they designed, or the manufacturers designed this system, was that we're not going to allow the equipment to be operated other than to get it off the road until you pour some more DEF in it. So you can't ignore it. And there's a lot of warning systems that you have to drive through before you're dead in the water. So this is Bosch's tool, or OTC, same thing. You know, many of us have a version of this tool that we've used to measure electrolyte and even more recently coolants. So there's one. There's what the reticle inside the, when you view through the refractometer, and the fluid that they are reviewing right now to set the null point is water, and hopefully deionized, pure, all the other things that they want in their specifications. They are very specific about it. So here's a scale without any liquid, and then on the right, of course, there is diesel exhaust fluid, or AdBlue to use the Daimler terms.
Jeff, we have a couple questions in the chat.
Oh, okay.
So one person wanted to know that they've heard a lot about urea, and does it have a similar compound makeup as actual urine?
So back to this, about 91 to 96% of urine consists of water, or inorganic salts, organic compounds, proteins, hormones, and a wide variety of other metabolites. So I don't see anything there that tells me that it's 32.5 Urea, the largest constituent, is more than 50% of the total, but it's still not 33% by volume. So
another person wanted to know the composition of urea change at different times of the year, like diesel having an anticoagulant in the winter. So does it not freeze?
No, it does freeze. So this is the part of the design of the mixture, if you will, is that it can freeze and thaw and freeze and thaw and freeze and thaw and freeze and thaw, but it doesn't separate. So it remains as a mixture at 32.5%. Have I tested that? No, I have not. I'm at the point in life when I see people smarter than me and they tell me it works. I've got to kind of accept that until I can demonstrate to myself that it doesn't work. So I hope that answers it. It's not the correct mixture. It's not the correct component. I wouldn't encourage anyone to use the DEF tank as a depository for that particular fluid. Okay, watch the chat, Jimmy, if there's anything else that comes up about that. My point is, you need to tell this to your students, right? That you're going to hear all sorts of these stories, okay? And, you know, being around equipment operators and truck drivers and various other trades, I've heard a lot of stories. And you take those often with a grain of salt. Sometimes they're spot on. You know, I've learned a lot from other people, other mentors. But this would be one that it still kind of raises the hair up on the back of my neck that somebody is pouring. Well, let's take your engine oil. You know, I've heard that, you know, I could use olive oil in my engine and it'd be just fine. It's just like petroleum product. And, you know, you might get down the road a ways if you changed your engine oil and put olive oil in there. But it's not made to do that. It's not the right stuff. So you could put liquid in the DEF tank and it'll pump it. But your outcome's not going to be positive, I would say. So that's why we always try to stick with the manufacturer recommendations. And I believe that students need to be clued into that. It doesn't mean that we need to be sheep and follow everything, but you know, we have to have some discernment about when we're being BS'd and when we're not. So, and I think this is important for students as they're joining in the trade. Now to switch gears back to the testing, this DEF tester is electronic. Bruce Amaker showed us in class one of these a long time ago. I think they were more expensive than I was willing to spend at the college. I hear they're very accurate, but not much different accuracy than what you would get with the refractometer version. So it's just another way. So once again, I put the Bosch stuff first, and then of course, here's a link down below to Amazon. This is obviously a knockoff. You may have one, I don't know. And maybe it works just fine. You've calibrated to the water line. But here is a view of what that projects in the reticle, where you can see that you're either measuring electrolyte, propylene glycol, or ethylene glycol, SRF, so that's windshield washer fluid, and then urea. So these all fit into one tool. If I bought one, I would want to check it against a known good and baseline it on water. But if it works, that'd be great. So, Jimmy, before I move along, is there any questions about the testing DEF fluid?
Somebody want to know, is the fill for DEF close to the fill for gasoline?
Oh yes, we couldn't make that any easier for somebody to put the wrong stuff in the wrong place. Let me go back to here. So in a lot of cases, now a lot of cases you really have to try to do this. I mean, the DEF fluid has a blue cap. They are getting a little better at getting it away from the fuel fill because it's fairly catastrophic. The worst case scenario is if you add DEF to the diesel tank. And if you have added DEF to the diesel tank and you realize it before you turn the key on, because the diesel tank may have a pump, an electric lift pump, you don't want any part of this fluid in your fuel system. You want no part of DEF in your fuel system. Let me say that again. You want no part of DEF within your diesel fuel system. That will, if you run it through the engine and if it makes it into the high pressure pump and in the common rail, you're replacing the fuel system because it's highly corrosive. And these high pressure fuel systems, the metals that are used in a high pressure fuel pump are pretty high carbon steel, hard polished, very finely polished and fitted. And they won't handle water, and nor will they handle a corrosive liquid such as urea because it rusts the components. And a high pressure fuel pump is a very particular piece of equipment. If especially, you know, you're pumping 30,000 PSI or more. So the clearances, you've just destroyed the fuel system. Now the lesser of the evils would be, somewhat lesser of the evils, is to add diesel to the DEF tank. That is usually going to mean you need a new DEF tank and probably a pump and the hoses and maybe the injector. So that one might only be $7,500, and the other one might be substantially more than that. I know in the PACCAR world, the regional service manager for west of the Mississippi said that they know when they have DEF in the fuel system, it is not a warranty item. You will not be receiving a warranty for this. And you will pay retail price for the new engine because the fuel system is cast into the engine block and the cylinder heads. And they won't, PACCAR won't touch it. You're going to swing an engine. So it's a fairly expensive mistake. That one's probably going to be, for the parts, going to be 50 to 60,000. So be careful.
We're clear in the chat, so.
Oh, okay. Yeah, I don't need
Somebody
to talk
did
about
mention
this.
that they remember working on an Audi and the DEF tank had a heater.
Yes, that's everything that I've seen has a heater in it. Because, you know, it's got to be 50 states and Canada, so North America. So, and there are cold places there. It is going to freeze. So the DEF tank's going to have a heater, and the lines going to and from the DEF injector are also have a spiral wire or heating element within them. So that if I start this vehicle at 50 below in Fairbanks, Alaska, or 50 below in Minnesota, it doesn't really matter. It's going to take a short period of time to thaw the fluid and get the system up and operating again. But EPA says we need to do that in the shortest period of time possible. So let's talk a little bit about the selective catalytic reduction fundamentals. This slide from Cummins, we're able to use this because at Consulab we are Cummins OEM. It means we buy factory for our engine benches, and that allows us to have access to quite a few training materials, some that we can share, and we've been encouraged to share this. So this is just a little bit different look at the system. I'm going to highlight it as I go through. So here's your symbol for the DEF fluid, your 32.5%. At the second point here is the hydrolysis. I'll let the chemistry teacher talk more about that. NOx catalyst, where the nitrogen oxides are going to react with the ammonia. And then any ammonia that's left over is caught up in the ammonia slip portion. What I'm seeing in modern exhaust systems, I think the slip catalyst is becoming smaller and smaller as they gain more control over the input of DEF fluid. So we're not wasting as much and they're running it pretty tight. Here's another view. These are from the middle 2000s, I think 2010, 2012. You want to take a second and take a look at that. These are the types of things that I think are important for students to learn. You know, I often reflect back on teaching electrical, where I started teaching electrical in 1994 by using math and Ohm's law, and I can't say that I was that successful with my learners until I figured out that we really needed to get our hands on things. We needed to use the multimeters. We needed to do voltage drop tests, and then once they had they found their way, they have an idea of what the system looks like. We've looked at schematics, then they can make intelligent decisions about, do I need to really do the math on this to figure out the resistance, or do I know that it's within a range, or the current flow, or the voltage? So I think the same thing goes here. We understand the architecture of the system. We know what it does along the way. And we know that if we, say, have an exhaust leak in any of these areas, that we're bringing in outside air, we're bringing in unmeasured atmosphere into the system, and that's going to skew our operation of the system. Any other questions? I think I've got a video to show, and then we're going to wrap it up.
Currently nothing new.
Okay. Now here, I'm going to switch gears and show a video that if I've toggled the right buttons in my PowerPoint presentation, it should work. And hopefully I have that keyed up there. Yes. So let's see.
Which is the second part of the after treatment system. So talk to us about SCR.
Yes, good point. Let me talk about SCR. Where the DPF takes care of the soot, the purpose of the SCR device is to reduce oxides of nitrogen, or NOx. In order for the SCR system to reduce NOx in the exhaust, a reactant or fluid is required. The industry name for this fluid is diesel exhaust fluid, or DEF. Here's how it works. Between the DPF and the SCR catalyst is a connection pipe where a dosing valve introduces a small mist of the DEF into the exhaust. DEF is a composition of urea and water. The DEF breaks down into ammonia in the exhaust. So as a small amount of ammonia enters the SCR catalyst, a chemical reaction takes place between the ammonia and the NOx to form nitrogen and water. And it's the nitrogen and water that exits the exhaust pipe. That's how NOx is reduced to near zero.
Okay, I understand generally how the SCR system works, but you mentioned a new fluid, DEF. How does the driver operator, what do they know about this fluid?
Good question. There's a new lamp and gauge on the dash, much like your fuel gauge, that indicates quantity of DEF on board. At varying levels of DEF, a lamp will illuminate to indicate low levels of DEF. And if the DEF lamp begins to flash, the DEF level is critically low.
Okay, I understand that. I think, though, Mike, there are a few more points or tips that folks in the fire industry want to know about 2010. Tell me more about DEF.
DEF is a 32.5% urea water solution. It's non-toxic, non-polluting, non-flammable, and it's safe to handle and store. The rate of DEF consumption is about 2 to 3% of fuel consumption. The actual consumption rate is dependent on a number of factors, such as vehicle duty cycle, geography, and climate. The DEF tank size for each vehicle is determined by the vehicle OEM. In the fire truck industry, DEF tank sizes of 5 to 10 gallons will be common.
So with a tank size in the 5 to 10 gallon range, how often will a fire department have to refill the DEF tank?
Well, if you do the math, the DEF tank volume is equal to about 2 fuel tanks. This is going to vary from application to application, but generally speaking, customers should expect to have to refill the DEF tank once for every 2 fuel tank refills. Another way to think about this is to consider a 50-gallon fuel tank. If you consume 50 gallons of fuel, you'll consume about 1.5 gallons of DEF. If you have a vehicle that will be operating on a scene for an extended period of time that may require refueling on scene, you should consider carrying a small amount of DEF on the truck, such as a 1 or 2.5 gallon jug.
So you mentioned before that Cummins emergency vehicle engines don't have derates or shutdowns for excessive soot load. So are there any derates associated with the SCR system?
It's critical that these engines are always operated with DEF in the tank. A part of our EPA certification includes assurances that the engines will not be operated without DEF. At very low DEF levels, you may experience a power or vehicle speed reduction until the DEF tank is refilled. Once refilled, the power and vehicle speed will resume as normal.
What would you like fire chiefs to know as the key takeaways from our discussion today?
Cummins engines and aftertreatment for 2010 will perform well and provide the reliability and durability that firefighters demand. Regarding the diesel particulate filter, it will regenerate on its own, and there will be very little need to perform a part regeneration. New for 2010 is the need to maintain DEF levels. So it's important to remember that just like any other fluid on the vehicle, always make sure that the DEF is topped off. Cummins is proud to be the diesel engine of choice for the fire and emergency vehicle market. We are committed to make every fire truck and emergency vehicle better.
Okay, so there's the start of the sales pitch. So in review, the student materials, curriculum, if you will, student exercises. I haven't looked back recently. I believe there's 9 or 10 assignments in this that come with this trainer that show what we feel to be the important things for students to learn. And that is the architecture of the system, the importance of the system being airtight and complete, and what those gases are. Now, the last part of the system that I want to talk about briefly is the diesel particulate filter. And there seems to be some misconceptions about what this is as well. And I try to have people view this as a ceramic air filter instead of a paper element that you would have in your air inlet. You have a ceramic element in your exhaust. Same principle. Particulate matter is going to be caught because it can't escape through the size of the openings in the substrate. But the issue is that the soot is going to build up, and you can see it here, because it can't travel through the substrate and out the exhaust. So anything but the particulate travels through, the particulate does not. So with the regeneration cycle, we're going to take this black soot and turn it into gray ash, and it will reduce. So think of a charcoal briquette. If you still barbecue with briquettes like I do, you start out with a solid briquette, and then you end up with a very small amount of ash. So on larger trucks, marine, shipping, and mining and ore trucks, those filters are removed. These filters are removable and cleanable. So you want to take good care of them because they're fairly expensive, and you want to make sure that the system is operating and functioning correctly, so that all these things work in harmony with each other. And we've all heard horror stories about that one vehicle that has just had all sorts of problems. I bought a tractor recently, and there's listings of within each brand of tractor, there may be a series of the same tractor with different horsepower engines, and some of them have had problems with a particular horsepower range within the same body of the tractor, whereas the higher horsepower doesn't have any problems with the exhaust system. The lower horsepower tractor doesn't have any problem with the exhaust system, but there's a tractor in the middle of the line somewhere that the conditions, it just hasn't been designed quite right. And so we want to be aware of what we're buying in the marketplace and what it is we get to repair. Here's another view of the particulate filter. These are channels that the exhaust moves into and through. So it's just like moving air through an air filter, and we catch the dirt coming in. Here we're catching the dirt before it goes out, so that we can have that exhaust pipe that I could take a pair of white gloves and wipe my finger in, and there's nothing there. When I do presentations in smaller groups where I can see the audience and I can get some feedback, especially if I'm teaching a classroom full of students, I do a lot of ongoing assessment. To some people, assessment means test, and to me it means something different. I want to assess what the student is learning. So if I didn't do something correct and the student has a misconception, I want to know about that, and I want to know about it early. So some of the questions I came up with is, what's the function of the decomposition tube or decomposition reactor? In this first session I did this spring on this particular topic, there were some things I didn't adequately cover. And so those show up as comments. So this was, I think there was 14, 15 people. I had them fill this out so that the next day in the next class, we could come and clear up any misconceptions. So I'm also an advocate of this for you to use with your students, is a dialogue of feedback so that you know what's going on. Here we are, this is one way. I can tell you that the Console Lab education team would rather be standing in front of you, every one of us. We would rather be in your classrooms doing these presentations, but we're not able to now. So we need to work on our presentation. And I've got to tell you that I'm really heartened by how the team has really stepped up. And you saw Dick's presentation this morning, excellent. Al yesterday, Tim, he's really nailing the student learning platform. So, but we do that because we are constantly out there getting input. So to end that, you know, if there's any questions that you have for me in the chat, I know it's going to take a few seconds for it to roll.
There's a couple that have been sitting here.
Yeah.
One of them is kind of a little off topic, but why do diesel pumps grenade?
Well, why do diesel pumps grenade? Well, I'm going to take grenade to mean that they explode. That's obvious. I go back to, you know, my father was an aviation machinist mate in the Navy, and he worked on a lot of aircraft flying through the Pacific. And he was a stickler for being clean in our engine work. When my brother and I were growing up, my brother is a Caterpillar dealer technician. I worked on the dark side and the contractors end of things, but we knew how to clean parts. And my dad was one of those that cleaned parts with leaded gas. And we, of course, in the 60s, late 50s and 60s, we didn't have any gloves. So, you know, we had our hands in a gas bucket. And my dad was kind of the local Cummins guy. And so we learned how to clean parts. And if you have dirty fluid, if you have dirty fuel going into the engine, if you have fuel contaminated with the least little bits of anything, that is going to adversely affect your fuel system and may grenade the pump. So, you know, Bellingham, I don't know if any of you realize that Bellingham is a real base for the Alaska fishing fleet, Seattle and Bellingham. And I've been telling the fishing, the boat owners that, you know, cleaning the fuel is your responsibility. And if I had $1 million boat and I depended on $1 million red salmon seasons in Bristol Bay, or if I was part of the Bristol Bay or Bering Sea crab fishery, I would have my own cleaning systems. I would have centrifugal filters and all sorts of fuel polishing available, because I can't take a failure in my power system. You've watched The Deadliest Catch, and I can tell you that the Bering Sea is not a pretty place to be without power. So I take it back to cleanliness. You've got to have clean fluids.
Okay, a couple more here. Could you find leaks using a smoke test?
Yes, there are some folks that have used some various brands of smoke tested very successfully. I think Brent Delfel at Snow Isle Skills Center is kind of leading a charge in the heavy industry part of that for smoking the exhaust. Or smoking most anything that smoke would come out of. So yes, not in the liquid system, but definitely in the exhaust system itself.
Okay. Next one is, what is the difference between SCR and EGR?
Well, selective catalytic reduction implies that it's a ceramic substrate that we're removing NOx out of the system. EGR, exhaust gas recirculation, is a system where we recirculate burned exhaust back into the combustion chamber to lower combustion temperatures, because our NOx is formed by excessive temperature. So really the best running diesel engine is where, you know, we pump all the fuel we can with a lot of air and the least amount of smoke available, and we can make some really good horsepower. But when we make that horsepower, we increase the combustion temperatures and we drive the NOx levels very high. And that's what we're trying to control, is the NOx levels. So early on in systems, before we had selective catalytic reduction, those engines, over-the-road engines from the 2000, see if I get my dates here right, were around 2005 to 2008. Nobody wants a 2008 because those were heavily dosed EGR and reduced retarded timing. So you ended up with a pig that used a lot of fuel and didn't have a lot of horsepower.
And just some was when someone else mentioned other things that could contaminate pumps, just again down to cleanliness, metal filings from poor lubricity, those types of things.
Oh yeah.
And also liked your point about cleaning your own fuel.
Yeah. If you're in critical, the manufacturers are doing a better job at doing the rough cleaning. Maybe they got a 20 micron primary and maybe a 5 micron secondary, but maybe they've also gone a little finer than that as well, and water separation and all those things. It's fuel quality is just a huge deal.
Yeah, another one that I've seen is how often do you change the filters on your on-site storage?
Yeah. Yeah. Well, that's the old Caterpillar fuel cap, buy clean fuel, keep it clean. And, to the point of topping your tanks off at the end of the day, because the hot fuel will condense overnight and you will gather water in the bottom. Just those things that, I use the TMC recommended practices. So the Maintenance Council of the American Trucking Association. I used to not buy those books because they were $450. I was trying to run a tight program, but then when I did buy the books, I bought them every other year because they were so important to show students that here is an industry that's come up with a recommended practice of how to store your fuel. I mean, this is the industry trying to help each other, and it should be the most basics of everything. And fluid, fuels, lubricants, coolants it's very important, and DEF fluid as well. It can't be contaminated. It's got to be the right stuff. 30 years ago, Rick, you remember, fuel systems on trucks were, you take a Cummins PT fuel system, you could just about push sand out the end of the ejectors. It's not quite like that, but the tolerances within a fuel system 30 years ago compared to today is no comparison. They're much tighter.
Okay, well, we don't see anything new, so I guess with that, we'll stop this presentation and get ready for the next one. I don't know if Jake, if you got something to say while we're waiting, or